Imagine if the universe had a delete button, a place where not only matter, but the very information that defines it vanishes forever. Black holes may not just consume stars, they could be erasing reality itself. Now imagine you throw your favorite book into a fire. The pages turn to ash, the words are gone. But technically, the information isn't lost. It's scattered in the smoke, the heat, and the ashes. Now imagine doing the same thing, but with an entire planet, into a black hole. Unlike the fire, a black hole doesn't seem to leave anything behind. Everything, matter, light, even the very information about what it was, appears to vanish completely. And according to the laws of physics, that's not just strange, it's impossible. This is the black hole information paradox, a problem so big that it might force us to rewrite the laws of reality. If we don't solve it, our understanding of space, time, and the entire universe might collapse. And the terrifying truth, black holes might not just hide information, they might delete the universe itself. A black hole isn't a hole at all. It's a region in space where gravity is so intense that nothing, not even light, can escape. They're born from the deaths of massive stars, collapsing under their own gravity into a point of infinite density called a singularity. Surrounding that singularity is the event horizon, the ultimate point of no return. Once something crosses it, there's no coming back. Einstein's theory of general relativity tells us black holes warp space and time like an infinite pit in the fabric of the cosmos. But here's the twist. According to quantum mechanics, information about a physical system can never be truly destroyed. That's the rule, and black holes seem to break it. Why does this matter? Well, information in physics is like DNA. It tells you exactly what something is. If you have all the information about a particle, its mass, charge, spin, you can, in principle, reverse time and know where it came from. If black holes erase that information, we face a nightmare scenario. The laws of quantum mechanics would be wrong. And if quantum mechanics is wrong, the entire foundation of modern physics collapses. This is why Stephen Hawking famously said, "If information is lost in black holes, then we are in trouble. Without determinism, we're lost." In the 1970s, Hawking made a shocking prediction. Black holes aren't completely black. Thanks to quantum effects at the event horizon, black holes slowly emit tiny amounts of radiation, now called Hawking radiation. Over unimaginable timescales, this radiation causes black holes to shrink and eventually evaporate. But here's the catch. Hawking radiation is random. It doesn't seem to carry any information about what fell into the black hole. So when the black hole finally disappears, the information it swallowed seems to vanish from the universe forever. That's the paradox. General relativity says information is gone. Quantum mechanics says it must survive. Both can't be right. You might think, so what? It's just information. But in physics, information is as real as matter or energy. If black holes can delete information, then the principle of conservation of information, a cornerstone of quantum theory, crumbles. Without it, predictions about the universe become impossible. This isn't just a small crack in the wall of physics, it's a wrecking ball to the entire structure. Scientists have been wrestling with this for decades, and several theories have emerged. 1. The information is hidden in the event horizon. Some physicists believe the information is somehow stored on the surface of the event horizon, encoded like a cosmic hard drive. This idea is linked to the holographic principle, which suggests that our three-dimensional universe might actually be described by information stored on a two-dimensional surface. 2. The information escapes in Hawking radiation. Recent work in quantum gravity suggests that Hawking radiation isn't truly random. It might carry subtle correlations that encode the lost information. It's like a cosmic encryption code, but one that would take billions of years to fully read. Third baby universes. Another bizarre possibility, when a black hole forms, it might spawn a new baby universe inside it, carrying the information away into another dimension entirely. 4. Firewalls. Some argue that a wall of high-energy particles, called a firewall, might form at the event horizon, instantly vaporizing anything that falls in. This would preserve information, but break the smooth nature of space-time predicted by relativity. In 2004, Stephen Hawking changed his mind. He proposed that information might leak out of a black hole after all, in subtle ways through Hawking radiation. This meant the paradox might be resolved without breaking physics. But the debate is far from over. Physicists still argue fiercely over the details. This isn't just an abstract puzzle for scientists in labs. It's a question about the ultimate fate of reality. If we solve the information paradox, we might unlock quantum gravity, the long-sought theory that unites general relativity and quantum mechanics. It could lead to breakthroughs in everything from time travel to understanding the birth of the universe. And if we don't, we might have to accept that the universe is fundamentally unpredictable. That reality itself can be deleted. Black holes are not just cosmic monsters devouring stars. They might be the key to the deepest truths about existence. The information paradox forces us to confront the limits of human knowledge, and perhaps one day it will reveal the code that runs the cosmos. Until then, every black hole in the sky is a question mark, a reminder that some answers are hidden in the darkest places.